Good evening, my fellow scientists. It is Friday, July 21st, 2017, and I've been thinking hard on what I want to talk about today. And I think I'd like to tell you a little bit about quantitative analysis. I'm going to be teaching quantitative analysis in the fall this year, and I've been thinking about the big questions. I'm not going to try in a 4-minute video to explain the curriculum of quantitative analysis, but I think that it's worth thinking about the question of how frequently the question of how much is in this comes up, right? How much of a chemical is in a substance, in a leaf, in a salad, in a steak, in a hamburger? How much of something that's nutritious or something that's poisonous is there? It's not enough to say that something is there. It's important to say how much of it. It comes up all the time in our modern world. The questions like how much bromate is in water. Bromate isn't healthy. We don't want too much of it in our water. Came up a few years ago when a bottled water company was first getting started in an area. They started purifying the local tap water and then adding their salt mixture back into it, as they do. And then they would oxidize it with ozone in order to get any biological critters out of it, and then bottle it and sell it. But when they added their salt, they added bromine ions, which are delicious, in small quantities, and then they oxidized with ozone and they created bromate. Bromate is toxic. So the local water authorities said, well, you can't sell bottled water that's got more bromate in it than tap water. So they forced this company to take all their bottled water off the shelf and dump it. Now, this, for one thing, is evidence of how silly bottled water is. But for the second thing, it is evidence of just how important this sort of quantitative chemical analysis is. We make big economic and safety decisions based on limits that are then assayed with some quantitative chemical technique. And that number makes for big money decisions for somebody. The chemistry department where I first got my chemical education, supposedly, I was told, the department was set up back when the university was first founded in the late 1800s as a department to educate analytical chemists to determine how much gold was in ore that was being brought in by gold rush gold miners. Now, again, I don't know how true that is, but it's more evidence of just how economically important this question of how much is in there is. But I think philosophically, that question has a sort of subtle rider. That is, if I say that, oh, there's 7 parts per million of bromate and the limit is 5, how certain am I that that 7 number is precise? Do all the bottles have 7 parts per million? Do some of them have 4? Do some of them have 12? Now, how consistent are the bottles and how consistent is my measurement? How certain is that science? Being trained to ask and answer that question is hard, and it leads a scientist to have a different perspective on all claims of measurement, on all claims of toxicity, cause and effect, knowing that all of these measurements, however important and however carefully performed, are subject to limitations in their precision, that they are limited in their application. I think that's worth students knowing. So I'm going to try to design this course as best I can to really highlight that question, that point. So anyway, thanks for tuning in. I hope that's an interesting perspective on what analytical chemistry is all about. We'll get back to talking about batteries and crystals and science and chemistry and all the fun things we like to do in the Allens.